All right, let's do 35, which says we have 17% of a radioactive substance decays in 5 hours. What's the half-life? So I'm reading that as there's some kind of radioactive stuff, right? Blob, right? And 17% decays in 5 hours. And they're asking for the half-life.
Where is that in half of 5 hours? So
Yeah, so what's a half-life?
half of its life.
Yeah, it's how long it takes for half of it to disappear. Which, it should be noted, is if you double the half-life, you don't get the life. Yeah, see that? Yeah, because that's how long it takes for half of it to disappear. So half of it disappears in the first half-life, and then half of what's left disappears in the next one. So there will still be a quarter left after 2 half-lives. You guys see that?
And it's never going to reach 0. That's a fun thing.
Yeah, and the mathematical model says it never reaches 0. The physical reality is a bit different because at some point, right, there's one molecule left, and it either decays or doesn't, which is a Schrodinger whatever thing. Cat box. Or Schrodinger's phone, as is maybe more common for you guys. You guys know Schrodinger's phone? It's what happens when you drop your smartphone on the ground and it lands screen down. Because this feeling goes through your body, right? That your phone is both simultaneously shattered to bits and might be totally fine, but you won't know until you flip it over. So, point is,
You broke your
how do we do this?
A sub O equals 1/2 A sub O, parentheses, 0.17 minus 1, 1/2.
Hang on.
How much is that book?
Okay, so I think what I'm looking for is I'm looking for half of the amount,
Right.
right, is
Oh.
the amount and half to the t. This is a bunch of crap, right? T's 1. I just wrote down what half-life means. Shit. So I think I want something like this. The amount at some time, right, is the amount at time 0 times 1/2 raised to the half-life. Like the amount of half-lives. No? It's not what you want?
We need the rate.
Yeah, we need the rate. Like, I should have to use this 17% in there somehow. Yeah, so this is continuous decay, right?
Yeah, compounding.
Okay, so maybe this is just the wrong equation to be using. Okay, so you guys want to use one of these?
Yeah.
Oh, that looks like a much better idea. Cool. So this is like really a PERT model, right? Okay, so what does a 17% decrease in 5 hours mean? Like, what things can I replace in here?
T with 5.
Okay, you guys think T is 5? You don't know R.
70%, 5 hours. So.
Yeah, it's 17% in 5 hours, which means that the amount after 5 hours is whatever the amount was you started with, times what?
0.83.
0.83.
Oh, yeah.
Because 83% 1 minus.
You guys see that?
Yeah.
So this is after 5 hours, right? Starting with an initial amount of A0 and decaying at a rate that I don't know. There's 83% of A0 left. Really, basically here, guys, I'm writing down A of 5 in 2 different ways. You guys see that? On the one hand, I have a model, and I plug 5 into it. And on the other hand, I have something they told me in the equation, in the problem. Right, that 17% of it went away. So now what? I need to solve for R. Okay, so how do you solve for R?
You still want variable, your two
Yeah, there's two variables, right? What's the other variable?
starting.
Yeah, the amount that it started with, right?
But if you divide it over, it cancels.
Yeah.
Uh,
Thankfully, if I multiply both sides by 1 over a0, they slash out, right? At least assuming I didn't start with none of the substance. So I get 0.83 is e to the 5r. Then what? Log both sides? So log both sides, you get natural log of 0.83 is what? 5 times r. And then you multiply both sides by 1/5. And so you get r is natural log of 0.83 over 5.
Negative 0.0373.
And so your r is approximately what?
Negative 0.0373.
Okay, so this decays continuously at like 4%-ish. Yeah, that seems more or less legit. You guys with me?
Yeah.
Yeah? Okay, now, did I answer the question?
Yeah.
Yes? What did they ask?
You got how long does it take for half-life?
Oh, it says, what's the half-life, guys? I don't have that. Crap.
Oh,
You can plug it.
I was happy with what we got.
Yeah, so I need to plug this back in and somehow figure out half-life, right? So, as I was trying to write before, half of the starting amount, right, is the starting amount e to the minus 0.073, and really I'm doing approximations, right, times t. You guys see this? This is like me saying, at some time, right, there's half as much. So on the one hand, I have a model that tells me how much there is at a time. And on the other hand, I have, there's half as much. And then I need to solve this. So what do you do first? Multiply by 1 over a0. So you get 1/2 is e to the minus 0.0373 t. And really, crap, I'm still doing approximations here. So then what?
Log it.
Yeah, do the same steps from before, right? Okay, so I get natural log of 1/2 divided by negative 0.0373 is, crap, is approximately t. You guys with me? Cool. Now what? Slap it in a calculator. So if you slap this in a calculator, what do you get?
About 18.6
Okay, about 18.6 watts.
hours.
Hours. How'd you know it was hours?
The units they gave you.
Yeah, good. We fixed the time units at the beginning by using 5, right? 5 was in hours, so I fixed my time units in hours. Make sure they're all the same before you start, right? So to answer this in a sentence, I write half-life is 18.6 hours, approximately.
Thanks for that.
Cool. If you wanted exactly, where would you get exactly?
You gotta leave it.
Yeah, you'd have to leave this mess in for R, right? And so you'd have that mess in right here. Cool. Questions, Steele?